It's been almost a half-century since the publication of Thomas S. Kuhn's The Structure of Scientific Revolutions, a slim little book that introduced the word paradigm into common parlance and shattered our conventional way of looking at change. 50 years on, it still represents perhaps the best thinking on how transformation happens, who drives it, why it's so vehemently resisted, and what it really asks of people. The book explores the psychology of belief that governs the acceptance of new concepts and innovations in science. Kuhn showed that the history of science is not one of linear, rational progress moving toward ever more accurate and complete knowledge of an objective reality. Rather, it's one of radical shifts of vision in which a multitude of non-rational and non-empirical factors come into play. Kuhn showed that the theories of Copernicus, Newton, and Einstein were all self-contained and incommensurable with one another. There was no steady accumulation of truth in the form of objective knowledge about the physical universe. Instead, each theory was a revolutionary break from the previous theory, resulting in the arbitrary replacement of one conceptual matrix, or worldview, by another. Once the matrix changed, the way science was done and applied was fundamentally different. Kuhn used the word paradigm to describe this conceptual matrix. A paradigm, in his formulation, is a constellation of facts, theories, methods, and assumptions about reality that allows researchers to isolate data, elaborate theories, and solve problems. Aristotle's Physica, Ptolemy's Almagest, Newton's Principia, and Lavoisier's Chemistry are examples of scientific classics that gave rise to new paradigms. Each of these works triggered a revolution, rendering irrelevant much of what came before them. The chief characteristic of a paradigm, Kuhn argued, is that it has its own set of rules and illuminates its own set of facts. Because it is self-validating, it tends to be resistant to change. Kuhn pointed out that as long as a paradigm is successful at explaining observed phenomena and solving problems, it remains dominant. But as new phenomena begin to contradict it, the paradigm succumbs to increasing doubt. And as anomalies multiply, it is thrown into crisis. At this stage, what is needed is the articulation of a radically new theory or insight, such as Einstein's theory of relativity, that can explain the apparent contradictions. In this way, long periods of normal science are followed by brief intellectual upheavals that reorder the basic theoretical assumptions of the field. New paradigms rarely appear on the scene full-blown. Their early formulations are typically crude and incomplete. They are often the products not of deliberation or interpretation, but of a relatively sudden and unstructured event like the Gestalt switch, Kuhn wrote. Scientists then often speak of the scales falling from the eyes or of the lightning flash that inundates a previously obscure puzzle, enabling its components to be seen in a new way that for the first time permits its solution. New paradigms are never immediately accepted by the scientific community. They may gain ground because of some dramatic and unforeseen verification, or for personal or aesthetic reasons. They may appear neater, simpler, or more elegant than their older counterparts. But the choice between competing paradigms ultimately comes down to personal conviction since, as he put it, the competition between paradigms is not the sort of battle that can be resolved by proofs. While the new paradigm tends to be more successful in accounting for and predicting phenomena, there is ultimately no absolute standard for determining whether one paradigm is better than another. Kuhn stressed that a new paradigm is almost always the work of a young person or someone new to the field. After a number of years in a certain discipline, a scientist tends to be too emotionally and habitually invested in the prevailing paradigm. Indeed, the established leaders of the older tradition may never accept the new view of reality. As Kuhn wrote, Copernicanism made few converts for almost a century after Copernicus' death. Newton's work was not generally accepted, particularly on the continent, for more than half a century after the Principia appeared. Priestley never accepted the oxygen theory, nor Lord Kelvin the electromagnetic theory, and so on. Adherents to the old paradigm usually go to their graves with their faith unshaken, Kuhn wryly noted. Even when confronted with overwhelming evidence, they stubbornly stick with the wrong but familiar. The fact that Kuhn's treatise, an academic essay on a fairly specialized subject, the psychological factors at work in the advancement of science, went on to win a wide audience is one of the great surprise stories in the history of ideas. But Kuhn had put his finger on something that was widely intuited, if not openly acknowledged or articulated, namely that change proceeds by upheaval. It's not a smooth and gradual process. Transformations are violent because they necessitate the destruction and reordering of our most basic conceptual frameworks. That was an insight even a general readership was happy to embrace. Not all of Kuhn's conclusions have stood the test of time. For example, recent work has called into question the idea that scientific paradigms are incommensurable, and that paradigm shifts are therefore essentially irrational events. For example, Canadian philosopher Paul Thagard says there is enough continuity in scientific revolutions to suggest that the process is not really arbitrary or nonlinear. He likens a paradigm shift to the process of learning a second language. But never mind. Kuhn's basic insights stand, and his service to our understanding of the psychology of change has been incalculable. The Structure of Scientific Revolutions was described by Scientific American's John Horgan as the most influential treatise ever written on how science proceeds. Philosopher Richard Rorty called it the most influential English-language philosophy book of the last half-century. It sold the most copies, made the greatest difference to our ways of thinking, and was the subject of the most intense and complex debates. For a quarter of a century, Huston Smith wrote in 1982, it was the most cited book on college campuses and turned paradigm into a household word. The book, in other words, is an evergreen.